In this video, I will be discussing a portion of Chapter 3 on visual displays of data. And we'll be addressing specifically the common types of graphs and the data that they depict. So there are 5 common types of graphs that I'm going to be introducing today: the scatter plot, the line graph, the bar graph, the pictorial graph, and the pie chart. Scatter plots are graphs that depict the relationship between two different scale variables. So we're talking about two continuous variables that are either on an interval or a ratio scale. We observe every data point, and on the x-axis we plot one of the variables, and on the y-axis we plot the second variable. And what we're looking for is to see whether there appears to be a particular trend in the data. We might find that it seems like the data falls in somewhat of a straight line, that we could draw a straight line through it that could kind of fit the data. Or we might find something that's actually a curve of some kind, and it's a nonlinear relationship. So here's an example of a scatter plot that shows the number of hours studied on the x-axis and the grade that an individual got on an exam on the y-axis. And you can see that, generally speaking, it seems that the more people studied, the better they did on the exam. And you probably could fit a line to this data somewhere in the middle here that shows a linear trend. So we often use this to examine our data to see what kind of relationships we have between our independent and our dependent variable, and whether that relationship is linear, because it tells us something about whether or not we can conduct either a simple regression or whether we could compute a Pearson's correlation. The next type are line graphs. Now, with line graphs, we're searching for trends again in the data. And similar to what we just talked about, that you could fit a line into that scatter plot and see that there might be a linear trend, that's when we fit that line, that's called the line of best fit. It minimizes how far away those data points are from that particular line. Another use of a line graph is a time series plot, where we're looking at how whatever variable you've plotted on the x-axis or on the y-axis changes over the course of time, and time will be on the x-axis. So here's an example, again, that same scatter plot that we had before, and you can see we've now put that line of best fit into the data, and it reduces how far those data plots are from the line, generally speaking. Here's an example of weekly newspaper circulation over time. And you see that up here we have the year, ranging from 1990 to 2010. And you can see over time what that newspaper circulation is for each of these different graphs, or different newspapers. Wall Street Journal began to use online subscribers, so they went up quite a bit. Los Angeles Times has dropped off. Many of these, New York Times, New York Post, they're all trending downwards. All right. The third type are bar graphs, and they are used when you have an independent variable that is nominal or ordinal and a dependent variable that is scale. Now, your independent variable will be plotted on the x-axis, and the dependent variable always goes on the y-axis. There's a specific kind of bar graph that we can use called a Pareto chart. It's a bar graph in which the categories along the x-axis are ordered from highest to lowest, so that you can easily see the differences between different categories. We might, in a bar graph, arbitrarily order things in the sense that if you use alphabetical order for regions, for example, then that might be one way that you could put things together so that people could find things pretty easily. If you had some sort of data on state rates of graduation from high school, for example, then you could either put those in order alphabetically, or it might be actually more useful to put them in from highest rate of graduation to lowest rate of graduation. So here's an example. We have this survey called the General Social Survey, and this is a standard bar graph that shows what region of the United States different people were from in this sample. And it's kind of hard, you can tell, like, is this bar higher or is it lower than the Middle Atlantic? So if I compared Mountain and Middle Atlantic, how do those compare? It's kind of hard to tell, or especially South Atlantic and West-South Central. It's hard to tell. So if we put things in order from greatest to lowest, it's a lot easier for people to see those relationships. And you can see that the South Atlantic is actually less than the West-South Central. But it wasn't as clear from the top graph. Bar graphs are used to highlight differences between means. So when we look at t-tests or analysis of variance, we'll often use a bar chart. Here we've got number of tattoos on our x-axis, and so this is ordinal, right? We've got no tattoos, 1, 2 to 3, 4 plus. And then we have percentage of people or percentage of respondents that have a certain number of tattoos. Be careful though. This is the same graph, but they've exaggerated the differences by putting these little slash marks across the y-axis and extending that scale to make those differences look bigger than they actually are. Here is an example of a pictorial graph. So here you're choosing clarity over cleverness. That's the idea anyway. If you're going to use a pictorial graph, you really ought to be careful about its use. What it does is it uses a visual depiction of the data for an independent variable when there are very few levels. Now this is kind of an interesting graph because what it does is it shows us actually an interactive graph. If we go, let's go back. If we go to the website where this particular graph is found. So you'll notice that here is the carbon cost for these innocent smoothies versus a can of Coke. So if you look at the top layer, it says 10.2% of carbon emissions for the production here is transport of raw materials. Here for Coke, it's retailer vending, refrigeration. If you roll over these little circles, then you notice that these values change. Smoothie manufacturing, carbon cost is 21.3%, but manufacturing for Coca-Cola is only 7%. So you can get kind of interesting information. So this would be one of the things that your book would list as being a future of graphs. Okay. So we're going to come back here and, resume our slideshow. Okay, so here's another example of a pictorial graph. And the problem with this particular graph, if you look at City A and its population is 1 million people, but City B's population is 2 million people, you'll notice that this graphic depiction of this little man is not twice the size of City A. Even though maybe it's twice in terms of one direction, the area that this graphic encompasses is more than this area. So it distorts that difference. It makes it seem like this City B is much, much bigger than it actually is. So be careful about distortions due to pictorial representations. Pie charts. You guys all probably know pie charts. Oops. They're a graph in the shape of a circle, which each slice represents a proportion of each category. And they're really not the best choice. I will say this. The only good kind of pie is the kind of pie that you eat. And again, this comes back to the same reasons. Here's my most accurate pie chart, right? Pie I have eaten and pie I have not eaten. So really, the problem is that we really understand things linearly as human beings. And pie charts really rely on area. So we're not as good as estimating or discerning differences based on area. And it's really hard. You know from practice, really, that this is a third of the pie that's been eaten, and this is 2/3 of the pie that has not been eaten. However, it's really hard to necessarily know that when we start talking about smaller and smaller slices of pie. So here, this is the same data depicted in both graphs. And I want you to think for a minute. You might want to pause and think about which one of these two you think better depicts the data. So if you said, now this was kind of, you know my bias now, if you said that you thought the bar chart was the better depiction, then I would agree with you. Because again, it's a lot easier to depict this linearly instead of trying to figure out 5 to 7. I mean, if it wasn't labeled over here, it'd be really hard for me to kind of figure out what that is. So I caution you against ever using pie charts. All right, so to check your learning, which of the previous graphs do you think would be the best type of graph to depict these two different scenarios? You may want to pause your video now and read through these and make a decision for the first one and for the second one. And I'll go through the answers in just a moment. Okay, so when you look at depression levels and stress levels for 150 university students, and I want to know, is depression related to stress? I'm going to look at a scatter plot. That's because my depression level and my stress level are going to be some sort of scale variables, and I want to know is if their depression levels are higher, the more stressed out they are. For the second one, the mean years of education for 6 regions of the United States, if I want to know if some levels are higher in some regions than others, here we're talking about mean differences. And so what we really want to look at is a bar chart. Now you might even consider a Pareto chart because it might be easier, depending upon the number of categories you have, to discern differences among different regions. So, but here we're looking at mean differences, and so education level would be on the y-axis, and then our regions would be on the x-axis. So here's the last piece, and perhaps you might think this is the most important. This is the summary. So how do we choose the graph that we need to use based on our variables? Well, if we have a single scale variable that has frequencies associated with it, then we will make a histogram or a frequency polygon, which you've already reviewed in Chapter 2. The y-axis is your frequency, and the x-axis is your scale variable that's either going to be based on individual observations for each number or intervals, and you plot those midpoints of those intervals on the x-axis. When we have one scale independent and one scale dependent variable, we use a scatter plot or a line graph. One of our scale variables might be time, in which case we'd often use a line graph. Otherwise, we might use a scatter plot, and here we're looking for, is there a linear or nonlinear relationship? The last two are looking at mean differences. When you have a single nominal or ordinal independent variable and one scale dependent variable, you're going to use a bar graph. If you have 2 or more nominal or ordinal independent variables and a single interval dependent variable, you'll also use a bar graph. So in this case, we might have 3 different categories, and we're interested in whether, first graders, 4th graders, and 10th graders spend more time playing Pokemon. Okay. In our second one, now we've got 2 different categories, and you probably can't see them too well, but there's a white bar here, it's a little taller, white bar here, white bar here. So now we're looking at, across 4 different categories, are men different from women, for example? So those 2 variables are going to be for intervention groups and males and females. So again, that would be a bar graph. Okay, so this last part is about creating the perfect graph. You want to make sure that the terminology used in the text is the same as the terminology used in your graph. You want to make sure that your graph conveys the entire story without making the reader go back to the text. And you have to, in the text, reference the graphs that you've included in a particular paper. Make sure you also use clear title and label.